Hey students, this is actually the last topic we're going to talk about for your test. I know it's coming up really fast. And so we're going to do this video. There's going to be one other video that you're going to have to watch, and then we're just going to have some worksheets and things like that to help prepare you guys for taking a test on these topics. This is our last big thing in nuclear chemistry. So if you don't already, pull out your notebook or a piece of paper to take some notes. This is going to be about fusion and fission. And like I said, this is kind of our last big topic that we're going to be talking about. So your test is going to be on fusion, fission, half-life, radioactive decay, and those are kind of our big topics that are going to be on our test. So fusion and fission, I wrote the definition, here, let me actually erase that. I wrote the definition up here, what fusion and fission kind of is. So it is this, the nuclear reactions that can produce large amounts of energy. So that's what fusion and fission is. They are these really big nuclear reactions. They're going to produce lots of energy. We're going to talk about things like atomic bombs and sun and things like that that have lots of energy in them, because that's what fusion and fission does, is it produces lots of energy. So hopefully you can get that definition copied down. If not, just pause the video, write it down, and we're going to move on to talking about what each of these things actually is. So let's start with fission. Okay, let's start with fission. I'm going to get you guys a definition down really quick. Alright, so fission, we can kind of see from this picture here that we're going to have this, this is actually a neutron. There's lots of ways we can start a fission reaction, but it's going to come and hit this unstable nucleus. And what this big nucleus is going to do is it's going to split into two different new elements or atoms. And so fission, its definition is splitting a heavier nucleus into lighter nuclei. So remember, write this down as I'm writing it down, so you can have it in your notes. So there you go. It's splitting a heavier nucleus into lighter nuclei. So here we have our heavier nucleus, and then we're going to split it into two lighter nuclei. Alright, so that's what fission is. The next thing we're going to talk about is fusion. So fusion will be our next definition that we're going to do. So while you're finishing writing down the fission, I'm going to kind of talk about fusion over here. So what fusion is that we can see we can have this particle and this particle. They're coming together and they're going to form a heavier element. So it's when we have two lighter things coming together to form a new element. And so the definition we're going to write down is combining lighter nuclei to produce a heavier nucleus. Alright, so that's our definition for fusion. So you can see fission and fusion are kind of opposites almost. So with fusion, we're actually going to take, like I said, we're taking these two different particles right here, and they're going to come together to form one. So what's usually happening is it's usually, like we talked about with nuclear chemistry, we're talking about our nucleus. So we're having two of these positively charged nucleuses, because remember, in our nucleus are just protons and neutrons, and they're going to come together. And as we talked about before in this class, positives and positives, they usually repel each other. They usually don't come together. So think in your head right now, just take a few seconds to think in your head about how might we be able to fuse two nucleus? How might we be able to get these two positive charges to actually stick together instead of bouncing apart from each other? So hopefully you've had some time to think about it. Like we said, they usually repel each other, but if we use enough heat and pressure, we can get them to stick. So we need a lot of heat. That's super important. I would write that into your notes. Of fusion, we have to have a lot of heat and pressure to get it to stick together. And so we're usually going to see these reactions happening on really hot surfaces like the sun or something like that. You can actually look into it if you're interested. They are trying to make fusion reactions happen on Earth. They have different processes to try to get, that super hot reaction happening. But for the most part, these things happen mostly like on the sun and stuff like that, because it takes lots of heat and pressure to get these two positive charges to actually come together. Alright, in the next video, we're going to talk about how we see this in real life. Like I said, we're going to talk about, sun, stars, some atomic bombs and things like that. So make sure to watch the next video. These are just your basic notes for fission and fusion. It's not too difficult, but make sure to get it down because you will have homework on this and it will be on your test. Let me know if you have any questions, and good luck.